I'm going to give you fair warning on this one. This one's hard. This one is very hard. We're looking at writing an equation for a linear function from a verbal description. We're taking word problems and we're making equations. So we are making the equation that we've been working with, y equals mx plus b, from a word problem. Some of these are going to get a little sticky. We remember from the last video that I did that this is a slope. This is my rate of change. This is something that happens over and over again. B is my initial value. It is my y-intercept. And it's also something that just happens one time, just once. Alright, so on number one says the graph of the function passes through point 2, 1, and y increases by 4 when x increases by 1. The easiest thing that I can do is to make a table. I'm going to say x and y. I need my y-intercept. So I need the point where x is 0. They give me this point right here. They give me 2, 1. So this is my x. They give me this. So at the point where x is 2, y is 1. The problem also tells me that y is increased by 4. So I'm going to come here to this 1, and if I add 4 to it, I get 5. That would make my next number. Then it tells me that happens when x increases by 1. So if I say 2 plus 1, that gives me my next value of 3. So the first thing I need to find is my slope, or my rate of change, to fill in my equation. I know that slope needs to go here. So I'm going to take the two values that I already know, and that is 2, 1, and 3, 5. And I'm going to find my slope. I'm going to say 5 minus 1 and 3 minus 2. That's going to give me 4 over 1. I can simplify that to 4. So 4 is my slope. That is my rate of change. Now, here's where it gets kind of tricky. I've got to find this. I've got to find where my y-intercept is. I know over here that every time x increases by 1, y is going to increase by 4. So if it's increasing by 4, I can assume that it's going to decrease by 4 as well. So to go backwards, if I take 1 and I subtract 4, I get -3. So at the point where x is decreased by 1, y decreases by 4 and becomes a 3. So I need to do that one more time to get my y-intercept. So I'm going to say -3 minus 4, and that's going to give me -7. -7 is my y-intercept, my starting point. I know, it's tough. Just hold on. We got it. We're going to keep doing this together. Alright, next one. A function with the rate of change of 3 over 2 whose graph passes through the point 4, 10.5. Alright, we know that we're trying to make this equation again. Lucky for us, look what the problem already gives us. My rate of change. I already know that my rate of change is 3 over 2. I don't have to do anything. It also gives me this point of 4, 10.5. So I'm going to come over here and I'm going to make another table. I've got my X and my Y. I know that I need the point where X becomes 0. That's going to be my Y-intercept. That's super important to get. So I know that X is 4. Let me add our rest of our numbers. 1, 2, 3, 4. I know that where X is 4, Y is 10.5. That's what it gives me, right? It also tells me that when my Y goes down 3, my X is going to go down 2. So I'm going to subtract 2 here, and that's going to take me to 2. So I'm going to eliminate 3. When I go down by 2, my Y is going to go down by 3. So I'm going to say 10.5 minus 3. That gives me 7.5. I'm going down because I'm decreasing my value to find 0. If I'm going up, my slope is positive, so I'm going to go up in value. Right? Let's do this again. I'm still trying to get to 0. So if my X goes down by 2, that takes me to 0, so I don't even have to worry about 1. My Y is going to go down by 3. So 7.5 minus 3 brings me to 4.5, and I've hit it exactly on. So my Y-intercept is 4.5. So this is my equation. Right, number 3. Number 3 is worded kind of funky. It tripped me up too. The function with the rate of change of 4/5 has a value of 10 at x equals 10. So for my new graph, my new table, I've got my x and my y, and I'm working on my equation again. Lucky for us, again, it tells me that my rate of change is 4/5. My slope is 4/5. So I know that every time my x changes by 5, my y is going to change by 4. It also tells me at the point of 10, my y is going to be 10. So, let's count backwards. Let's do this, the opposite of my slope, to figure this out. So I know that my y is going to change by 4. So my y is going to change by 4. 10 minus 4 is going to give me 6. My x is going to change by 5. 10 minus 5 is going to give me 5. My y is going to change by 4. 6 minus 4 is going to give me 2. 5 minus 5, because my x value is changing by 5, is going to give me 0. So I have hit it spot on right here. This is my y-intercept. That is my starting point, and it is a positive 2. The easiest way to do this is to make a table and work backwards once you have your rate of change. Alright, number 4. A function has an x-intercept of -2 and a y-intercept of -3. Of -2/3. I'm still looking to make this equation. So here's where it's talking about x and y intercept. We haven't talked about an x-intercept. My x value, my y value. An x-intercept is where my y is 0 and I have an x value, and that's giving me -2. My y-intercept is where x is 0 and my y is -2/3. So it's already giving me one thing that I've been looking for, and that's this right here, my y-intercept. So I know that y-intercept already done for me. Now I need to figure out my rate of change, my slope. So I'm going to have to take the 2 points that I already know. I'm going to take 0, -2/3, and -2, 0. And I've got to do a little bit of mathy here. I've got to subtract my y values, -2/3 minus 0 over 0 minus -2. If I put that in my calculator, I come up with -1/3. So my slope, my rate of change, is -1/3. I know, just bear with me, just bear with me. We're working these together. I know this is tough. We got this. Alright, number 5. Cameron stops to get gas soon after beginning a road trip. He checks his distance from home 2 hours after filling his gas tank and checks again 3 hours later. The first time he checked, he was 170 miles from home. The second time, he was 365 miles from home. What equation models Cameron's distance from home as a function of the time since getting gas? Again, I'm working on making this equation. So, it's given me a couple of things. The first time he got gas was 2 hours after filling his tank, and checks it again 3 hours later. This is going to be one of my my x values, and then 3 hours later, so that's going to be 2 plus 3 is a 5. So those are my 2 x values that I already know. The first time he checked was 170 miles, so that's going to be one of my y values. The second time was 365 miles. That's my my other y value. So I need to figure out my rate of change. I'm going to take 365 minus 170. I started with this one, so I've got to start with this one. 5 minus 2, and that's going to give me 65. So 65 becomes my rate of change. So I'm going to make another table over here. I've got my x and my y, and I know that one of my x's is 2 and one of them is 5. I've got, at 2, I've got 170. At 5, I've got 365. I need to know what 0 is, and I can find 1 in the meantime. I know my rate of change is 65, so I'm going to take 170 and subtract 65. That's going to give me 105. And then I'm going to do it one more time to take me to my 0. So 105 minus 65 gives me 40. And that is my starting point. That is my y-intercept. I know, it's a lot of work. It's a lot of work, but we got it. We got it. It gets a little bit easier from this point on. A charity organization is holding a benefit. It receives $28,000 in donations and $225 for each ticket sold at the event. What equation models the total amount earned from the event as a function of the number of tickets sold? So again, I'm working to make this equation. This problem helps me out quite a bit. It tells me 225 for each. My slope, my rate of change, is something that happens over and over again. So for each is something that happens over and over again. Got lucky there. Didn't have to do any work. My y-intercept, my starting point, my initial value, is something that happens only one time. I got lucky in this one too. They also gave me a hint here. It receives $28,000 in donations. That happens one time. So, there's my equation. I pulled numbers specifically from the problem because it already gave it to me. Alright, let's look at the next page. The same charity organization from problem 6 has to pay $4,700 for the banquet hall, as well as $110 per plate for each ticket sold. What equation models the total amount spent as a function of the number of tickets sold? I'm still working on making this equation. And again, it gives me a really, really big hint here. It's telling me that my something that happens each time is right here. Per is the same thing as each. So I know that my rate of change is 110. It also tells me that something happens one time. We're only going to pay for the banquet hall one time. So that is my y-intercept. That is my initial value. Right? Next one. Using your answer from problem 6, write an equation for the charity's profit as a function of the ticket sales. The profit equals the amount earned minus the amount spent. Alright? I had two equations. I had y equals 225x plus 28,000. And if you remember, that was this one right here. That's where I'm getting that equation. The other equation that I came up with was y equals 110x plus 4,700. So this one is my profit. This is my expenses. And just, you know, common sense, the way that we know this works, we have to subtract these two. Alright, so 225 minus 110 gives me 115. 28,000 minus 4,700 equals 23,300. So this is the actual profit. Let me change that. That is earnings. And this is our profit. Alright, number 8. A school pays $1,825 for 150 t-shirts. This includes the $25 flat rate shipping cost. What equation models the total cost as a function of the number of t-shirts ordered? Alright, this one does something a little different. It tells me 1,825 is the total. So my y in this one is 1,825. I've still got to make this equation. part of my answer is looking for y equals mx plus b, but they're giving me the they're giving me the y, so something else is going to be missing. Let's see if we can figure that out. It's telling me that 150 shirts were ordered. 150 shirts were ordered, but it doesn't tell me how much. That's the part I've got to look for, and it tells me that my flat rate shipping, that happens one time. So now I'm actually looking to figure out how much is each shirt. So we know how to solve an equation. Let's do it. We're going to subtract 25 on both sides. 25's cancel. I'm left with 150x equals 1,800. Going to divide by 150 on both sides. 150 cancels. I'm left with 1,800 divided by 150 equals 12. So I know that this value is 12. The shirts cost $12. And I know that the flat rate shipping, that happened one time, that's it. I'm done with my equation. Alright, what does each variable represent? Well, in this case, y is the total cost, and x is the number of shirts. Normally we're looking for the amount of change, but in this one we were looking for the amount of shirts. Alright, last one. What is the initial value and rate of change of a function, and what does each one represent? Okay, we're looking at this particular problem. The initial value is $25, and that is the shipping cost. That happens one time. That is my y-intercept, my initial value, my starting point. The next is rate of change. Rate of change is 12, and that is cost per shirt. That's this right here. We had to do all this mathy right here, solve the equation to get how much each shirt costs. I know, I struggled through this one too. I'm sure you can tell. I know this one was tough, but we made it. We did it together. We got it. If you have any questions, shoot me a message on Google Classroom. I love you guys. Hope to see you soon.